In this video, I'm going to answer the question, what are the YouTube video views descriptive statistics? And I'm going to use SPSS to do so. So this is a practice question included in the How to Stats textbook. And what I'll mention before I carry on is that I actually got the data. These are real data obtained from a web page that produces random YouTube videos, in the sense that it searches the various YouTube videos that exist out there, and it's creating a random database or semi-random database. And so I found the 50 videos from this web page, and I jotted down all the data, relevant data I was interested in. And for this practice question, I've got video views associated with each of the 50 videos, and I can calculate descriptive statistics with this based on a sample size of 50. So what is the first question to answer? What was the mean views? So what's the average view of a YouTube video? So let's check that out. Views, statistics, mean, click continue. I'm going to deselect the frequency table and click OK. So the mean video view is 13,713. So that's the answer to the first question, 13,713. That's how I got that question. What was the median views? So there's an interesting question, because as you know, the median and mean will deviate from each other as the distribution becomes more and more non-normal or asymmetric. So let's check the median. Go into statistics, click on median, click continue, and the median has come out at 190. So the typical video of the 50 random selections has 190 views. What a massive difference between the mean and the median. And that should be hinting to you that the distribution is very seriously positively skewed. What was the standard deviation? Let's check that out. Analyze, descriptives, frequencies, statistics, and the standard deviation right there. A very whopping standard deviation of 83,265. And that huge standard deviation, if you think about the mean itself is only 13,000, and the standard deviation is actually bigger than the mean. That happens when you have a massive amount of variability in the scores and probably positive skew. So let's check out the fourth question. What was the skew and kurtosis? Well, let's check that out. I suspect it's pretty serious. Analyze descriptive statistics, frequencies, statistics, skew and kurtosis. And the table just keeps getting bigger because we keep getting more and more descriptive statistics. And the one that you want to look at is right here. Skewness is 7.018. I've mentioned before that as far as inferential statistics are concerned, skew less than 2 is usually not so bad for a particular statistical analysis. And I talk about that throughout the textbook. This is skewed at 7.018. That's pretty bad. Serious. And kurtosis is 49.475. So that's the answer to those two questions. Oh, it's one question, but there we go, 7.018 and 49. Let's take a look at the distribution just for fun. You know what, I'm actually going to do that once we answer the rest of the questions. So, were there any outliers with respect to the views? I haven't given you the answers here because I have to work them out, because there are outliers in this data file, and I'm going to have to deal with them probably with Windsorization. So to look for outliers with this real data set, let's go to descriptives and explore. That's the difference. You can't find outlier analyses with frequencies or descriptives. You have to go into explore. And let's put views into the dependent list. And let's click on statistics, and we want outliers. Continue. And on plots, I want to deselect stem and leaf. I don't hate the stem and leaf, but it's not my preference. And here's the histogram. I want to check that out. Click continue. And here are the results associated with our outlier analysis. So the first thing I'm going to look at is this histogram. And you can see that there's this massive value. There's a video out there that has a huge number of views relative to the others. And that value is pulling the mean in a very serious way. So the mean and median are very different. You get that automatically in the Explore utility. The mean and the median re-reported in the Explore utility. And once we look at the extreme values here, we can see that there's one video that has 589,282 views. A very popular video. And this one here is 33,000. That's case 24, video 24. 33,000, 20,000, 16,000, and then 5,823. So it looks like we have positive skew pulling the distribution, but one of them is so massive we can't even see the tail properly. Let's look at the outlier plot that SPSS produces, and this outlier is so serious that it's really affecting the viewing of the distribution in this box plot. What I'm going to do, as you know, one way to deal with an outlier, even though it's hinting at me that there are more outliers here to deal with, I'm going to deal with this one first. I just want to deal with that one first and then look at the distribution of scores again. So what I can do if I'm going to use Winsorizing is I could reduce this 589,000 value down to 33,061, say. Now, I should say also that the reason I would use Winsorizing now is not because I think this is an erroneous value. I've double-checked this video. It really does have 589,282 views. It's not a mistake. It's not an outlier in the sense that it really is part of the YouTube universe of videos. So when I calculate the mean and median associated with these data, this really is what the mean video view is for a YouTube video based on a sample size of 50 generated from this website, which may not be perfect at generating random videos. And so to the extent that it can actually produce random videos, these data will be accurate. But if I wanted to do subsequent analyses on these data, such as inferential statistics, I might have to deal with this outlier because many statistics assume normality, and the skew and kurtosis need to be less than 2 and 9 if you follow the rules that I report in the textbook. So I'm going to fix up this one massive outlying value, and I'm going to reduce it to 33,061. Here it is here. And let's see what happens when I fix that up. 33,061. And I'm not going to save the data file. You would normally save it into a different variable. So maybe I actually should do that to show you how to do it. So I'm going to create a new variable, and I'm going to call it views adjusted or views Winsorized. Go here, view Windsor, and I'm only going to Winsorize the one value for now, and I'm going to Winsorize it to this thing, 33,061. And I'm going to reanalyze those data. Analyze descriptives, frequencies. And I'm going to put views Windsor in there. I'm going to reanalyze that and see what it looks like. Now we can see something that's a little bit more apparent. I can see that there's still a trailing. The skew's been reduced very substantially down to 3.5. It was 7.0 and now it's down to 3.5 by Winsorizing that one value. But I've still got quite a bit of skew, and we can see that there's still a trail of outliers in these data. And what I can do is I can progressively reduce all those values. I think definitely they're going to have to be adjusted down to 5,824, say. So now I've got to reduce all those big values down to 5,824. Let's see if I can, that's not too bad. 5824, 5824, and 5824. So that's another, I've applied another layer of Windsorization because that first variable, fixing that one did not, or I should say Windsorizing that variable did not fix the problem. And so now my skewness is getting close. 2.144, I'm almost down to what I need to get it down to, and we still have this distribution coming down to here. I still positively skewed, and we can still see that there's still more and more values that are outliers. And so you could keep doing this process of reducing the highest values down to a value that you think, well, maybe that's not an outlier, and keep doing it iteratively. Or, as I mentioned or I allude to in the chapter, you could potentially do bootstrapping on the analysis, which doesn't assume any level of normality. And that's probably what I would do. So you have the option of continuing with this Windsorization process and getting the skew down to 2.0, less than 2.0. Or you can apply a bootstrapping approach. So I'm going to pretend like that this skew of 2.1 is fine for me, and I'm going to answer the remaining questions, which is, were there any outliers with respect to views? Yes, definitely. And certainly the most serious flagrant outlier was this 5,822. But there were also other outliers that I found as I continued with the analysis. And if the answer to the question 4 is yes, apply Windsorization adjustment, okay. And what was the mean of the adjusted view data and what was the skew? So I'm just going to stop here and say that, well, 2.1 is pretty close to what I need, and I'm probably just going to do bootstrapping on these data anyway. And I could answer the questions with a mean of 984.12 and a skew of 2.14. Again, I could continue reducing these values to the next level lower to get even less skew. But I think you got a sense of how to calculate descriptive statistics on a real data set on a question that I think is fairly interesting about what's the typical view for a YouTube video. It's 190 with the median, but much bigger with the mean, because there are videos out there that are extremely popular, whereas most videos are not particularly popular.